So here's a trig equation with a singular argument. I have 2 cosine squared of x minus 5 cosine of x plus 2 equals 0. What I'm doing here is I see it as a quadratic. Ax squared plus bx plus c equals 0. And then my domain, x is an element from 0 to 2 pi. I do notice it's x, so I'm in radians, not theta for degrees. The square bracket means including 0. That round bracket means not inclusive of 2 pi. So before I even start here, I'm just going to look at the algebra equivalent. If this were something like 2x squared minus 5x plus 2 equals 0, I would see that as a quadratic. Quickest way to solve a quadratic is factoring. Only factors of 2x squared are a 2x and an x. Only factors of 2 are a 2 and a 1. Either the 2 goes here and the 1 here, or the 2 here and the 1 here. For this to be positive, they either have to both be negative or both positive. But to get that negative 5x, they're both going to have to be negative. The reverse operation of factoring is distribution or foiling, a quantity times a quantity. So my check is 2x squared minus 1x minus 4x is negative 5x plus 2. So I can see I did this correctly, or I factored it correctly. Zero sum property, either this equals 0 or this equals 0. So either 2x minus 1 is equal to 0. Add 1 to both sides, divide both sides by 2, and x is either equal to a half, or x minus 2 is equal to 0, x is equal to 2. I could take those solutions, plug them back in, and see if they work. So I'm going to use that same algebra knowledge, but rather than work with x, I'm working with an actual function. And the thing about a function is I'm going to have a series of solutions rather than just a singular solution. So I'm replacing x with cosine of x, but I'm going to factor it the same way. So the factors of 2 cosine squared is going to be 2 cosine of x minus 1. And then over here, I'm going to have cosine of x minus 2 equals 0. Again, the check, 2 cosine squared of x minus cosine of x minus 4 cosine of x gives me that negative 5 plus 2. So in black over here, I have cosine of x minus 2 is equal to 0. Right, zero sum property. Either this black thing equals 0 or this red thing equals 0. I add 2 to both sides. Cosine of x is equal to 2. Again, this is a fraction where the adjacent is 2, the hypotenuse is 1. We're talking about right triangles. The hypotenuse always has to be longest side. The adjacent can't ever be longer than the hypotenuse. So that's as far as I go. There's no solution for this part right here. So this kind of dead ends right here. Then the other quantity right here, I have 2 cosine of x minus 1 equal to 0. I'll add 1 to both sides to get cosine of x is equal to 1. Divide both sides by 2. And cosine of x is equal to a half. I'm still trying to isolate my variable x. So I got to take the arc cosine of both sides. The inverse cosine of cosine, they cancel each other out to give me x by itself. If I do that to the left, I also have to do it to the right. So I have the inverse cosine of 1/2. What that's saying is when my adjacent is 1 and my hypotenuse is 2, what is my angle in radian measure? Well, that's going to happen in a couple of places in my unit circle. One way to remember it is all students take calculus, where a positive ratio of sides for cosine would be in the first quadrant with an adjacent of 1, hypotenuse of 2, or in the fourth quadrant with an adjacent of 1 and a hypotenuse, that's a hypotenuse of 2. Hypotenuse of 2, right? Adjacent over hypotenuse, adjacent over hypotenuse. I use the Pythagorean theorem, 1 squared plus root 3 squared is equal to 2 squared. 1 squared plus negative root 3 squared is equal to 2 squared. I recognize that as one of the exact value triangles I know. This right here is a 60-degree angle. 60-degree reference angle. And those are my two reference triangles, a first quadrant reference triangle and a fourth quadrant of 60 degrees. Now I want all values between 0 and 2 pi. So what I'm going to do here is I start here and I rotate around till 2 pi, and I include every one of those triangles inside this domain. So the first triangle is 60, or the radian equivalent of 60. It is 1/3 of the way to pi. So my first one is 1/3 of the way to pi, or pi over 3. So that one's pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. So that one right there is 5 pi over 3. And then that's my solution set right there. As I take both of these radian measure angles and plug them back into this equation, they're going to work. If I take the cosine of pi over 3, cosine of pi over 3 is going to be a half. I square it, a quarter, times 2 is a half. So that's a half. Minus 5 times the cosine of pi over 3, a half, minus 2.5, right? 5 times that half is 2.5 plus 2. And I can see 1/2 minus 2.5 plus 2 is a solution because it's equal to 0. So there's a lot of pieces here. The first piece is recognizing that as a quadratic, factoring it so that you have the zero-sum problem.